NASA's asteroid news. The DART asteroid mission is Earth's last line of defense. According to what NASA is explaining, it's ready to fire a spacecraft into the asteroid, testing Earth's last line of defense should a rogue celestial space rock veer into catastrophic collision course with our planet, for Earth impact, of course. Now, Japan's Hayabusa 2 spacecraft made history last April after firing a bomb at asteroid Ryugu in an attempt to collect samples from that space rock. But much more violent asteroid rendezvous is being prepared by NASA with the twin asteroids Didymos. The U.S. Space Agency is planning the DART mission, where the space probe will be blasted on the mission into an asteroid, testing the last line of planetary defense. That's what it's all about. It's like a real test run on a small body. The Didymos is twin star. Didymos means twin in Greek. It's the main asteroid. I said star, sorry, it's an asteroid. The main asteroid is the size of a mountain, and it's got a little moonlet going around it, which is the size of a pyramid. So it's the little moonlet that they want to blast as a trial. NASA estimates our planet is bombarded with more than 100 tons of dust and sand-sized particles every single day. 100 tons every single day added to our Earth. Can you imagine? But once every few million years, an object large enough to threaten life on Earth arrives, that is, to impact us. Michael Patrick, Director of Research for France's Côte d'Azur Observatory, believes that the Double Asteroid Redirect Test, or DART for short, can learn a lot from the Hayabusa 2 mission. He said that for us, this is an exciting first data point to compare with simulations, but we have a much larger impact to look forward to in the future as part of the forthcoming double spacecraft asteroid impact and deflection assessment, AIDA for short. That's the AIDA mission. He said in late 2022, the U.S. Double Asteroid Redirect Test, or DART, spacecraft will crash into the smaller of the two Didymos asteroids, the smaller one being the moonlet, of course. He said, as with Hayabusa 2 SCI test, it should form a very distinct crater and expose subsurface material in the even lower gravity environment, but its main purpose is to actually divert the orbit of the 160-meter Didymos moonlet, the Didymoon asteroid, in a very significant way. The DART spacecraft will have a mass of 550 kilograms. It'll strike the Didymoon asteroid at 21,565 kilometers per hour, which is 13,400 miles an hour. So smashing into that asteroid 5 times smaller with a spacecraft more than 200 times larger and moving 3 times faster should create sufficient impact energy to deflect the asteroid in the first such experiment of planetary defense. The proposed European Space Agency, the ESA mission called Hydra, would then visit Didymoon to study the diverted asteroid, measure its mass, and perform high-resolution mapping of the resulting impact crater. Dr. Patrick, who is also serving as Hydra's lead scientist, said the actual relation between projectile size, speed, and crater size in low-gravity environments is still poorly understood. He said having both small carry-on impactor, SCI, small carry-on impactor, and Hydra data on crater sizes in 2 different impact speeds regimes will offer crucial insights. And he explains these scaling laws are also crucial on a practical basis because they underpin how our calculations estimating the efficiency of asteroid deflection are made, taking account the properties of the asteroid material as well as the impact velocity that is involved. He says this is why Hydra is so important. Not only will we have DART's full-scale test of asteroid deflection in space, but also Hydra's detailed follow-up survey to discover Didymoon's composition and structure. Hydra will also record the precise shape of the DART crater right down to centimeter scale. So building on this Hayabusa 2 impact experiment, DART and Hydra between them will go on to close the gap in asteroid deflection techniques, bringing us to a point where such a method might be used for real, end quote. Didymoon will easily be the smallest asteroid ever explored, meaning the space rock will provide insights into the cohesion of material in an environment of negligible gravity, more than 1 million times weaker than that of Earth. This is according to Express UK and Tom Fish. Now we know that, okay, this may work, hopefully it will, but this is a tiny asteroid, very small. And the impact of this spacecraft into it hopefully will work. What happens if you have bigger asteroids, bigger bodies, and we don't have big enough spacecraft to crash into them to deflect them? What is it that we should be using against these asteroids to deflect them? That's the question. So, you know, they have to try this is a real hands-on experiment here that they're trying to do. Now, last year, they had a tabletop asteroid mission exercise, which they have every 2 years. In 2021, they'll have it in Switzerland, I think. Up to now, they've been having these tabletop exercises every 2 years, and they have not yet once saved the Earth from a quote-unquote theoretical impact. The tabletop exercises, they keep failing for some odd reason, so they have to have some way of defending our Earth from these Earth impacts. One of the major ones that we had about 13,000 years ago, called the Younger Dryas event, they believe that was due to a comet that broke up in various pieces and hit the Earth in various locations: North America, Europe, and South America, Australia, South Africa, and it broke up to at least 7 pieces from what they've found up to now. So this is a very serious thing. Hopefully with our modern technology, we'll have some way of protecting Earth from these inbound celestial bodies. I'll leave links below for you for this. If you'd like to join me on my Patreon account, you will hear content not covered by mainstream media. These riveting stories will be based on my research, and I will state my opinions and give my personal insight on diverse and controversial subjects and world events not covered by mainstream media, and not supported by YouTube guidelines. So whatever I have on my Patreon, most of those will not be on my YouTube channel. Please consider becoming a member today. More of the most significant and important videos will be on my Patreon channel. Your support helps me to continue my research and keeps this YouTube channel alive. And we depend on your support, your generous charity, because we help economically challenged families here in Athens, Greece, in Kapota, and we also help the young generation with university tuition and the community around our church. Thank you.